With the stash command, we saw one really great helper in Git. There is another one though, and that's git restore. Because git restore helps us if we deleted, for example, a commit or a branch. We learned how to do both throughout this course. We saw that we can kind of delete commits with resetting the head in our project. But what if this goes wrong? What if you need back such deleted information? Well, it turns out that with git reflog, we can bring back such lost information, so to say. Because whereas a commit is basically a snapshot of our current project, so to say, the reflog stores all our changes we made in our Git project. Now, how does the git reflog work? Let's first add another commit here. So let's create a new file, maybe called file2.txt, like this, and that's enough. And let's add this file and create another commit in here, file2 added maybe. Sorry, typo by myself, but as you see, this worked. So we have file2 added now with the exclamation mark in here. This is nice, but now we say, actually, I don't need this second text file here. So we can basically change our head and with that lose our commit here. We learn how this works with git reset. We will do a hard reset with git reset -- hard. And now we want to go back one commit with our head like this. We do that. You see our file2.txt file is gone. And in our log also, well, this commit is no longer available. Now, up to this point in the course, we couldn't get back this commit. But if we now enter git reflog like this, we see an overview of all changes we applied in this branch. This doesn't save the changes forever. It's a rolling back 30-day storage logic in here. But for the last 30 days, we always have all these changes. Don't get confused by all this information we have in here. It's related to our stash, things we tried out. But the important thing down here is that we have this commit here, commit file2 added, the commit we just created, and we have this hash in front of that commit, in front of that step, so to say. Now, if we simply copy this commit here, and now leave this menu, and now say git reset once again a hard reset, but now we won't enter anything from the head. Now we just enter or add this hash we just copied. Let's do this. Then our head automatically changed back to this hash and therefore to this commit. If I now again log this information, you can see that file2 added is again our head in the master branch, and this commit is brought back to our project. So this is how you can bring back lost commit, so to say, into your project. The reflog also helps us if we deleted branches though. Let's create a new branch in here. So with git checkout -b, and let's call it the feature branch maybe in here. Now in this feature branch, we'll create a new commit, maybe with a file3.txt file. So we will add this in here. So this is what we worked on. And let's commit this change now. So file3 added, right? Now we switch back to our master branch. And now we delete our feature branch. We learned how this works with git branch like this, -D, and now the branch name, which is feature in our case. If we do that, we now deleted that branch. It's no longer here. But if we now again access our reflog with git reflog in here, we can find the commit where we added this third file. It's this one here. This is the hash we have to copy. So if we copy this hash, clean this maybe, what can we do now? Well, we can't follow the same procedure we had before, right? Because we want to recreate the branch, and this hash actually refers to a commit that we created. So the branch is not here at the moment. But we can recreate that branch with 2 steps. First, we should check out this commit. We know how this works. We use checkout and now the hash. And now we are again in our good old detached head mode. But what we can do now is we can create a new branch which then contains this commit. We can again use the git checkout -b command, or we can use the switch command that we also learned in this course. So with git switch -c and now the branch name feature, like this. And if we do that, we have now 2 branches. You see git branch, the feature and the master branch. We are in the feature branch. And if we log the information, we see that we have all our commits, but the file free added commit is ahead now in the feature branch as it was before. So this worked. And if we now again switch back to our master branch and there check the log, you see we only have these 2 commits. So this is how the reflog works. The reflog allows us therefore to bring back kind of lost information, be it related to commits or to branches. So with that, I want to conclude our work on individual commits. In the next lectures, we will dive deeper into the combination of 2 different branches, so a master and a feature branch. So let's continue with that. Let's leave the individual commands for specific commits and let's come back to the combination of a master and a so-called feature branch. Now, what is that? Well, a master branch is basically the main project branch that you have. So it's the first branch you create in the project and also the branch which might contain your latest deployed status of your website, for example. So you created this branch and you have some commits in it, and then you decide, hey, I want to implement a specific feature into my website, for example, and I want to work on that feature. And once it's done, I want to add it to my master branch. Now, you know how this works. You can create such a feature branch based on the master branch, and this feature branch also holds all previous commits, here indicated as the gray bubbles. And this feature branch in the end is just a separate branch based on that master branch. Therefore, it's always important to keep that in mind. Now you continue working on both the master branch and the feature branch. This can be one or multiple commits. And then you could say, whilst working on your feature, I actually need these latest developments of the master branch also in my feature branch. This would be one option. Or you could say, I'm done with my feature, let's now implement this into the master branch. So the idea behind these next lectures is, how can we combine the master and the feature branch? And we already had a look at the merge command in the last lecture, so we will dive deeper into this merge command, how it works and when it can be applied. And besides that, we'll also have a look at another command which can be used to combine 2 different branches. This is the rebase command. Now, that's the theoretical background in this next lectures. Let's now dive again into the merge command first. So far, we just used git merge and then somehow the branches were combined, you could say. Turns out that there are different merge types in Git available. One of the 2 common merge types is a so-called fast forward merge. Besides the fast forward merge, we have non-fast forward merges. Here we have different merge types: the recursive merge, the hours merge, the octopus merge, or the subtree merge. Now, these could all be explored now, but actually to focus onto the core concepts of Git, it's totally sufficient to focus onto the 2 mainly used merge types, and these are the fast forward and the non-fast forward recursive merge. These are the 2 merge types we'll explore now, so let's get started with the fast forward merge, a merge we actually used already in the project. The fast forward merge works as follows. You again have a master branch with 1 or 2 commits here, and then you create a feature branch, you know how this works already, which also contains the previous commits, and then you're working on that feature branch and implement 1 or 2 new commits. Can of course be many commits here. With the second commit created in the feature branch, you are done, and very important, the master branch didn't further evolve. So the master branch still is at the stage that we had when we checked out that new feature branch. Now the question is, how can we merge the feature branch into the master branch? Well, in this case, this will of course happen with the git merge command, and in that case, Git will apply a so-called fast forward merge. What characterizes a fast forward merge? Well, as I said, the fast forward merge only works if we have no additional commit in the master branch after we created that feature branch. So our M2 commit in the master branch is the last change we had there. If that's the case, the fast forward merge simply moves the head forward to our F2 commit here, but it does not create a new commit. Now, in other words, this means once we're done with the feature branch, all commits are done. We just have to tell our master branch that the latest branch in this master branch now is this F2 commit in the end. Now, this sounds a bit strange in theory. Therefore, let's recreate the structure in a project and let's explore it right there.